Students, today we'll be running an experiment using the meter rule, sets of masses, different masses just as you can see here, and a knife edge. That's what we'll be using today. Now, because of time, we have done the practical. If you look at the board, you'll see that we've gotten our reading. But the experiment was done this way. Let me show you so that you can do that in your school or wherever you want to perform it. Now we have our meter rule. We have a set of mass also, but there is a fixed mass here which was placed at a certain point. Now the points were stated here on the question. We have 2 cm, 4 cm, 6, 8, 10, 12, different centimeters. So that is why you see me hang this mass on a thread here. Now at different mass you place them. Now this experiment is all about you. First of all, before placing this, you find the center of gravity of the meter rule, which most schools or most meter rule we believe that the center of gravity is at the 50 cm mark, which I also stated here because that is where we had our own. Now, having known that point, what we now do is we place this thread at the 2 centimeter mark. When you place it at the 2 centimeter mark, you get the point where it is now balanced again. Now note this, let there be no fan rotating beside you or anything that will bring in air. That's why you always use the word, you avoid drought, okay? So you look for a point where it's balanced. The point where it balanced, you can see. Whenever it balances that point, you take the reading. That point where it balanced is the D here. It's the D here. Now, the difference between the D and the center point of the meter rule, which we picked at the center of gravity, which was 50, you subtract the D from it, the next value you have there is your X. You get it? Yes. So you do that for different masses. You have that of, you have that for shifting it to 4 cm, to 6, to 8, to 10, and to 12. Now, having done that, you just shift this, balance it, and then you'll be getting all the same reading as you see them on the board. Now, having done this, we move straight to finding or drawing our graph here. Now, the graph here was plotted D against X. The D here, the point where it was balanced, against the remaining value before the center of gravity. That's what we plotted here. The D against the X. Now you see for the D-axis, you have the maximum point at 33.8, while that of X-axis, the maximum point is at 14.7. So we pick a scale of 2 cm to 5 units. You see, 5 times 20, 25, you get it. Then same thing for this side, we pick 2, 4, 6, 8, 10, we go up to 16. Now, having done that, we now plotted for the values. We plotted for the values, after which we now found the slope. How do you find your slope? Pick 2 points on the straight line graph and make sure that the right angle triangle you're going to draw is a large one. Don't just draw a small one. Let it be a large right angle triangle, which we did here. We now pick our point because the slope is changing D over changing X. We pick our 2 points, this minus this point, which is 33.8 minus 15, and also this minus this point, which is 14.7 minus this. Then after the arithmetic, we had that our slope is what? 2.3. Now, normally, the next question they will ask you here is to multiply this by 50. Multiply it by 50. Now, when you multiply it by 50, you'll be having 100 and something, right? Yes. Now, when you divide that thing you have by 2, it will give you the exact center of gravity that you used. So you see that our experiment was perfect. Okay? So in our next class, we'll now have to do experiment that has to do with both different sides, weighing the both sides and then also trying to balance them. So at this point, we'll stop here for today. God bless you. Stay in touch.